So hello everyone. So my name is Yu Feng from the Leibniz University Hannover. So the work I would like to present is ensembled CNN models for retrieving flood relevant tweets. This is work together with Sergiy Shebotnov, Claus Brenner, and Monika Sester. So we are currently really working on such a project, use crowdsourcing to find eyewitness for the flooding. So our project is real-time predict of Pluvial flood-induced water contamination in urban areas, so the EVUS project. So we are working with the hydrologists who did the rain forecast, and also the flood simulation, flood modeling. So for our task is to use the crowdsourcing to find some eyewitness to validate their hydrodynamic model, because they don't know whether they have good model present the right thing. And also for the risk and loss analysis, so people normally use the telephone call or questionnaire. So this can also be a source of information provided for the flood monitoring task. So, and also we collect also our own data sets. And also for the geoinformatics perspective, so we are also interested to detect the flooding event from the social media with the geotagged tweets. So we detect the spatial temporal clusters and also find the hotspot in the map. So this is why we are doing this. And so for the current task, so the multimedia satellite task, we only tackled on the first subtask, so flood classification for social media. So we regard it as a classification problem into 3 classes. So then I will introduce the straightforward method we have used. So for the visual information, we just use the pre-trained CNN models on the ImageNet. So we use the DenseNet image InceptionResNetv2 and InceptionResNetv2. And also we use the data augmentation, so such as rotation, shift, and zoom. And also we did early fusion, so just concatenate the feature vector. And so we also find if we only train the model once, so it is not relatively stable. So, and we trained it several times, 10 times, and make a majority vote for the final prediction. So the second run, so we use only the meta information. So we use the structure convolutional neural network model for text classification. So we also did the pre-processing, so remove the stop word URL and emojis. And we here use the Fasttext word embedding from Facebook. So it's a 1 million word vector from a huge corpus. And we did here also different convolutional size. So after we test on our internal test set, we find the combination of 1, 3, 5, the filter size performed on our task best. So we also did this ensemble of the predictions. So we trained it 10 times and make a majority vote. And after that, we use a fused visual and meta information as the organizer asked. So we joined the models previously round 1 and round 2 together, just to make also early fusion like this. And we also did the training for 10 times and do the majority vote. So after that, we also look at the task round 4 and round 5. So in this case, we only use the visual information. And in this case, we want to know if we introduce some imprecise labeled photos, if it can improve or make it very worse, the classifier. So we use the data from the last year. So for the tweets without evidence, we used about 3,000 negative labeled flickr photos from last year, because we see that these photos are almost no showing any possible evidence. And also for the round 5, we not only use the negative labeled flickr photos last year, we also use the positive labeled flickr photos. We use that as an imprecise label for the evidence not possible. So because we have just roughly look at, so we think most of them are relatively severe situation. So after that, we have our internal test set evaluation, so about 10%. So we see, okay, so visual information is very important, so which performed in our case the best. And also the second round, the meta information, it did not perform very well. So we think that only using meta information is not enough for such task. And also for the round 3, we see that, so in our case, it is not necessary improve by fusion the meta information and the visual information. And for the round 4 and round 5, we can see that, okay, so we did not make it that worse by introducing the imprecise labels. And also the test, the evaluation on the test set from the organizer, so it sees similar behaviors as our internal test set. And lastly, so our conclusion is that so visual information is very important for this task, and also the severity of the flood is hard to effectively extract it only using meta information, and also combining the meta information did not improve, and also add extra negative labeled images did not prove our result. And the outlook is that because in many hydrological experiments, people are also want to know what is the flowing speed of the water, so maybe it will be interesting to use the video sequence to make analyze for that. So thank you very much for your attention.